Hi there guys, and welcome back to another video. In this one, it'll be a quick one, just telling you of the different ways that you can write organic compounds or how you can represent them. So I'll be taking the example of pentan 1-ol. And so for pentan 1-ol, let's write down the molecular formula straight away, which is the number of atoms of each element in the molecule. So in this case, C5H12OH. And to make another correct answer would be C5H13O, because all it's showing, the molecular formula, is the number of atoms of each element within the molecule. So both these are correct. The second one is correct. The first one is also correct, but it's used just to make clear that the functional group is an alcohol. It's an OH. So that's the molecular formula of pentan 1-ol. Now, when you go to the empirical formula, this is the simplest whole number ratio of the atoms. So, in this regard, for pentan 1-ol, it's still C5H12OH, or actually, what's better is C5H13O, because none of these numbers, they're all odd. They can't be divided by 2. They can't be divided into the simplest whole number ratio. It can't be divided into a smaller whole number. So for example, let's take ethane, for example, which is C2H6, right? So ethane C2H6. If we break that down to the simplest whole number ratio, you get CH3, and therefore the empirical formula of ethane is CH3. Although CH3 is methane, but the empirical formula of ethane is CH3. Now we finished with empirical, molecular. We come to structural. All the structural formula does, it just shows how the carbon atoms are arranged. So basically, let's say pentan 1-ol again. So we just break it up: CH3, CH2, 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 C, so OH. Let's write it like that, just to make it all symmetric. CH3, CH2, 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 OH. That's the structural formula, just showing how the carbon atoms are arranged. And also, because all these CH2s are present, another way you can easily combine them: CH2, and say repeat it 4 times, and then, well, actually, you'll have to do CH2 repeated 3 times, and then CH2OH, because this CH2 is different. It actually has a OH or alcohol group bonded to it. When you come to the skeletal formula, this one does not show any carbon or hydrogen. It just shows the bonds. So, for example, 1, 2, 3, 4, 5. That's an OH. And that's pentan 1-ol in the skeletal formula, because it does not show any carbon or hydrogen atoms. It shows the functional group, which is fine, because it needs to make that clear. However, the actual carbon and hydrogen within the chain of the organic compound is not shown, because each of these turning points here represents a carbon atom. There we go. This one as well. These are all carbon atoms. And then, because each carbon atom in the skeletal formula is bonded twice to the other or adjacent carbon atom, there are 2 other bonds that each carbon atom is not being shown on the skeletal formula, and that's the hydrogen atoms. Finally, we come to the displayed formula, which is my favorite, and this shows all the atoms and all the bonds. So it's the most clear, and that's why I like it. So if I draw it down here, C, 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 and then actually, let's get it a bit closer so we have more space, and then finally you just draw all the hydrogens in. This is my favorite formula, or the way of representing organic compounds. It just makes everything clear. OH and H. Yeah, that's it. That's just a quick introduction on representing organic compounds. Thank you.